So today we are going to convert from polar to rectangular and vice versa. We're actually going to convert the coordinates so we can see how they work in the two different coordinate systems. You have some space up here at the top. So Nabil, I already said we're going to talk about the quiz at the end. So we have some room at the top. We're going to do some stuff up here, a little bit of reminders. So I'm going to draw a triangle in this first quadrant. And then we know that this is our x value, this is our y value, this is our r value. Like totally old business, right? So that means if I did Pythagorean theorem with those three parts, I would have x squared plus y squared equals r squared. Okay? Make sense? All right, there's a reason for all this. We also know that if we were talking about the unit circle, then we said the x value is cosine theta. The y value is cosine theta. But that is if you're on the unit circle. If it's not a unit circle, that's not the case. Cosine theta is equal to its adjacent over hypotenuse, which is x over r. The reason it would just be x with the unit circle was because r would be 1. So hopefully that makes sense. That means that sine theta equals y over r, or opposite over hypotenuse. Got to have that r in there. All right, so then tangent theta, we know that tangent is sine over cosine, or it is also y over x. I do. I have some little, oh, you know what? I have these over here. That they've been in here since spring break, so I didn't actually sanitize them, but I shouldn't need to at this point. All right. So then, anybody else need anything? All right, so then we're going to use this and this on the next part of what we do. Right now, we're just going to focus on these two, because if I take this and I solve for x, I'm going to multiply both sides by r, so I'll get r cosine theta equals x. Multiply both sides by r here, I get r sine theta equals y. So for those of you in AP Physics, mg sine theta, mg cosine theta, that's where all this is starting to connect. So then that means here, if I just write this down here, x equals r cosine theta, and y equals r sine theta. If we're on the unit circle, r is 1, so it's just sine and cosine, but not always on the unit circle. Okay? So it says to convert each pair of polar coordinates to rectangular coordinates. So we are going to take this 2 5 pi thirds, and this is currently in an r theta setup. Let's go ahead and plot that point on that little polar coordinate that we have. So 2 5 pi thirds. So when my angle is 5 pi thirds, my radius is 2. This is number 1. So remember, when we plot things, if we're plotting the same things, even though the coordinates are going to look different, if I was to be able to lift this up and set it down on top of this one, then they're going to actually be plotted in the exact same place. How to get there is different, but it's the same place. So that means that I know that my point has to end up in the 4th quadrant. That'll help me with reasonableness of an answer, because if I'm in the 4th quadrant, then that is, I know my x is positive and my y is negative. All right, so let's find x. So x is equal to r cosine theta. The r is 2. 2 times the cosine of 5 pi thirds. So x equals 2. All right, 5 pi thirds, I've already decided that angle is in the 4th quadrant, right? So in the 4th quadrant, is cosine positive or negative? Positive. So a positive cosine of a pi thirds angle would be a positive 1/2. When I multiply those, I get x equals 1. There's my x value. to get, because the cosine of 5 pi thirds is 1/2.
Use your finger, the fingers of pies.
Yeah, use your hand trick.
That.
Yes, absolutely. Thank you. That's exactly what I was going to say. All right, so then y. Y is equal to r sine theta, so r is 2 times the sine of 5 pi thirds. So I decide, here, y equals 2. So then sine of 5 pi thirds. In the fourth quadrant, sine is negative. So again, I use my hand trick, square root of 3 over 2. So this is going to be a negative square root of 3 over 2. So y is equal to negative square root of 3. There's my y value. My ordered pairs then is 1 negative square root of 3. That's my answer. So if I graph that here, I know 1, negative square root of 3, it's kind of a yucky number, but we can estimate. It's about 1.73. So I'm going to go to 1 and like negative 1.73, and that's number 1. And the only reason I'm having you do that is just so that you can see that they are plotted in the exact same spot. I think that this ordered pair is easier to plot and prettier to plot on the polar coordinate system than it is the rectangular system, because you have the yucky decimal, right? So that's one reason why, like, depending on what types of numbers you're dealing with, why you might choose one over the other. Okay, any questions at all? All right, so let's look at number 2. This again is in the r theta, and I need to get it into xy. So let's go ahead and plot this one. This is 3 pi fourths negative 6 3 pi fourths. So I'm going to go to 3 pi fourths, which is right here. The radius is negative 6. I pass through the pole. Here's where number 2 is. Now I'm going to land in the fourth quadrant. However, the angle that I actually have, so in the end I should have positive negative again, but this angle that I'm actually using is a second quadrant angle. It gets into the fourth because of the negative radius. All right. So we're going to have x equals r, which is negative 6, cosine theta, so the cosine of 3 pi fourths. X equals negative 6. All right, so second quadrant, cosine is positive or negative? Negative. And then 3 pi fourths, that's a pi fourths angle, which makes it square root of 2 over 2. So this is going to be negative square root of 2 over 2, which is then going to give me that x equals a positive 3 square root of 2. We good with that? All right, let's do y. Y is equal to r, which is negative 6, times sine of 3 pi fourths. Oh, I didn't need parentheses there, but whatever. So y equals negative 6. All right, 3 pi fourths, second quadrant. Is sine positive or negative? Positive. So positive sine of a pi fourths angle is going to be a positive square root of 2 over 2. And then that means that x equals negative 3 square root of 2. What? Oh, thank you. Good Lord. Just wanted to see if you were paying attention. Good job. I have classes that wouldn't have corrected me because they won't talk to me. All right. Why? Thank you. Everybody good? So then that makes this, my ordered pair, 3 square root of 2, negative 3 square root of 2. So if we graph that on the rectangular coordinate plane, so 3 square root of 2 is about 4.24, so it's like about 4 1/4. So I'm going to go to the right, 1, 2, 3, 4, and about 1/4, then down 1, 2, 3, 4, and about 1/4, and that's number 2. Okay, see, same spot. You're not going to have to always plot both of them. I just want to do that on some of these on the notes, just so you can, wrap your mind around what's happening. Remember, if they're in the same, if the graphs look the same, the ordered pairs and the equations look very different. If the ordered pairs and equations look similar, then the graphs are going to look very different. Okay. All right. Any questions? All right. I want you to do number 3. What's the cosine of negative pi halves? 0. So negative 1/4 times 0, I get x equals 0. All right. What's the sine of negative? So the sine of negative pi halves? Negative 1. So this gives me y equals positive 1/4. So my ordered pair then is 0, 1/4. Whereas on these 2 points, without actually doing like calculations, there's not necessarily a whole lot of reasoning you could do to come up with those points. But if you know that this point is going to be plotted in the exact same spot on a rectangular coordinate grid, then clearly your x value is going to have to be 0 and your y value is going to be a positive 1/4. I mean, you can kind of figure it out from the graph even on that one. So when we plot this one, it looks like this. There's number 3. What questions do you have? Anything? We all good on these? All right, I don't think we need to do number 4. Like, I think you're good. Let's move on to converting from rectangular to polar. So when we wrote some stuff at the top on that other page, I said, okay, we're going to use these 2 in the next section. That was the x squared plus y squared equals r squared. That was one of them. We're going to use that because to get it from xy into r theta, I need r. So to get r, I would take the square root of both sides. Now, every time we take the square root of both sides, what are we supposed to make sure we do? Plus or minus. On this one, though, r is the radius. The radius is always positive, so I don't have to do it on this one. That's the only reason it's not happening. So that means here, r is equal to the square root of x squared plus y squared. Will that become r equals x plus y? No, no way. That makes no sense, right? So that is your r. We're going to write it right here. R equals the square root of x squared plus y squared. We got it from the Pythagorean theorem of our little triangle and our little circle. The other thing from the front that I said we're going to use in just a second was the fact that tangent of theta equals y over x, because I need theta to get into my ordered pairs. So I'm going to have to take the tangent inverse of both sides. So theta equals the tangent inverse of y over x. So theta equals the tangent inverse of y over x. Any questions at this point? We understand where all this is coming from? Yes? No. Oh, yes. Maybe. Oh, here we go. Alrighty, so it says to convert each pair. So we're going to start, we'll go ahead and plot these as well. So on number 5, this is an xy, and I need to change it to r theta. So I'm going to plot this on my rectangular coordinate grid. 2 square root of 3 is about 3.46, so you can see like about 3.5. So we're going to go to the right 2 and up 1, 2, 3.5. That's number 5. Okay. Alrighty, so to get r, I have to use this x squared plus y squared. So r equals the square root of x squared plus y squared. So r equals the square root of 2 squared plus 2 square root of 3 squared. So that's the square root of 4 plus, what's 2 square root of 3 squared? Square the 2 and get 4, square the square root of 3 and get 3, you get 12. So that equals the square root of 16, which means r equals 4. All right, so then to get theta, theta equals the tangent inverse of the y over x, so that's going to be of 2 square root of 3 over 2. So that really just equals the tangent inverse of the square root of 3. What's the tangent inverse of the square root of 3? What's your angle when the tangent value is the square root of 3? Pi thirds. Okay. Here's the key on this though. So we have these two right now. But before we start coming up with answers, this says to convert each pair of rectangular coordinates to polar coordinates, and then it says if theta is between 0 and 2 pi, and we give two possible solutions. So on that first day when we plotted points, but then we also came up with different ways to get to the same point, that's basically what it's asking us. We had 4 total points then because we were going from negative 2 pi to 2 pi. Here we're just going from 0 to 2 pi, so there'll be 2 different ways to get to that specific spot. The other thing is you have to think about how the inverses work. So with the inverses, you're only getting answers. With its tangent, you're only going to get an answer from the first or fourth quadrant, right? Because the positive comes from the first, the negative comes from the fourth. What if we actually needed to be in the second or third quadrant? We have to think about what to do then as well. So on the first section, once you convert, you're done. But if you're converting to polar, you have to think about a few different things here. So one of the reasons that we're plotting these, of course, you wouldn't always have to plot it exactly. If you just look at this.
How does the inverse tangent for root of 3 turn to pi over 3?
Because you have to know your unit circle values. I don't know. I mean, because the tangent of pi thirds is the square root of 3, those are values we have to know. There's no magic there. I don't have a better answer. All right, so when I look at this and I plot this, and this is positive, positive, that means I know I'm in the first quadrant. So if what I get is a first quadrant angle right here, then I'm good. Okay, if I didn't, then I'd have to think through something, and we'll look at one of those. So my first ordered pair is going to be 4 pi thirds, right? So just like we did the other day, if I am at 4 pi thirds, that means when I'm at pi thirds, my angle is, or my radius is 4. I could have a negative radius and land over here. So if my radius was negative 4, then I would have a different angle. Then I'd be in the third quadrant. My third quadrant pi thirds angle is 4 pi thirds. Those are my two values. So let's plot that down here. When I go to pi thirds, you're at 1, 2, 3, 4. There's number 5. And look, if I do negative 4 pi thirds, I'm going to go to 4 pi thirds right here. My radius is a negative 4, so when I pass through the pole, I end up at the exact same spot. That's why I have to have two answers between 0 and 2 pi. Okay, make sense? We good? Okay. And if I ended up with a negative, so if I took the tangent inverse of a negative value, then I'm going to get a negative angle. And if my angle's negative, that's not between 0 and 2 pi. So although it would tell me where I am, I have to think about what the positive version of that is. Okay, so think about that. We're going to jump to number 7. We'll come back to number 6. All right, so on number 7, first of all, let's go ahead and plot this point. And square root of 3 over 2 is about 0.866, so it's about 0.9. So I'm going to go like negative 0.9, negative 1/2. So negative 7, or I'm sorry, not negative 7, number 7 is right about there. This is in the XY form. I need it in r theta. So my r value, r is equal to the square root of x squared, negative square root of 3 over 2 squared, plus y squared, negative 1/2 squared. So r equals, when I square this, I'm going to end up with 3/4. When I square that, I end up with 1/4. So that's the square root of 1, r equals 1. Okay. Then I'm going to find theta. Theta is equal to the tangent inverse of y over x. So that's negative 1/2 over negative square root of 3 over 2. So that is tangent inverse of 1/2 times 2 over the square root of 3. That's the tangent inverse of 1 over the square root of 3. What's 1 over the square root of 3? Square root of 3 over 3. And then what is the tangent inverse of the square root of 3 over 3? Pi 6. There's my theta value. So it looks like my answer should be 1 comma pi 6. But remember, we have to check some things when we are doing polar. So I'm going to think about this. We'll go plot. We plotted it, but even if I didn't plot it, if I just thought about the fact that it's negative, negative, I'm in quadrant 3. Ugh. I'm in quadrant 3. Is this a quadrant 3 angle? No. So when I actually really plotted this point, I'm right here. I know it's going to have to plot in the third quadrant. That's not going to get me there, right? But the reason that I got that is, again, when you take the tangent inverse, you're only getting values from the first and the fourth quadrants. That's it. But where else is tangent positive? In the third quadrant. So that's why we got this, but we really wanted the other positive angle. What's the other positive angle? In the third quadrant, pi 6 angle. 7 pi 6. So this is in quadrant 1. I want quadrant 3. My quadrant 3 pi 6 angle is 7 pi 6. That is the point that I have. So if I plot that one and go to 7 pi 6, then I'm at 1. This is number 7. I'm in the third quadrant, and you can see it's in that exact same spot. Right? Then I need my other one. The other way to get to this same point would be to have an angle that I end up over here, but I have a negative radius. So if I have a negative 1, I would land in the first quadrant. And what's my angle then? Pi 6. So it's still one of the angles. It's just the one for the negative radius. Ask me a question. Oh, okay. 7 pi. I know it's hard to see. Yes, sir. Oh, I thought you had a question. Okay. All right. What questions do we have? Anything? We're good? All right. I want you to do number 6. I'll help you get it plotted first because the numbers are yucky. Let's see. So that's 3 squared root of 2 over 2. That's about 2.12 because this is in xy. So about a little bit more than 2. So I would go to the right a little bit more than 2 and down a little bit more than 2. I'm about right there. This is number 6. Okay. So go ahead and convert. Okay, so you should be able to get yourself through this the arithmetic there pretty easily. Hopefully you got to know how to square those things correctly. But we end up with r equals 3. This looks all horrible and yucky, but we don't have to do anything fancy, right? If you have something over the same thing, you get 1. A monkey over a monkey reduces to 1. So that's a -1 because that's a negative sign. The tangent inverse of -1 is a -π4. But I don't get to use that angle because it says theta is between 0 and 2 pi. No negative angles. But I do know that this ordered pair, if I go positive, negative, I'm supposed to be in quadrant 4. So I actually end up here, but I need the positive version of that. What is it? 7π4. Yes, very good. So this is going to be 3, 7π4. And if I think about that on the circle, see this -π4 ends me right there, but so does 7π4, right? I need to know how I land here so I can use a -3. That's in the second quadrant. That would be 3π4. Does somebody have a question? No? Okay. All right, so if we plot this, we're going to get a 7π4, which is right here. 1, 2, 3. This is number 6, and it's in the same spot. Okay. What questions do you have? Anything at all? We good? All right. So let's talk about your assignments first, because
Yes.
Can
you go up a little bit, please? I forgot to write something.
Okay. Is that good? Okay, so on your calendar, your assignment says DM with a 2. That means Delta Math, and there's 2 things in there, and this is why. There's an assignment for today that has you convert, but I also threw in a couple of questions on that assignment where you graph, kind of like what you were sketching yesterday, but you're going to do it in Delta Math, which makes it a little easier, where you have to choose the right curve and whatnot. But then there's a second assignment that is, it says completing the square review. Okay, and if you disagree with me about whether or not it's a review, whatever, we're not going to argue about it. But I'm telling you, I put that in there because what we are doing on Monday requires us to complete the square. And that is a skill that you should have been taught before now. So I'm not reteaching it. If you know how to do it, you're going to zip through that just real quickly. If you don't know how to do it, then use the videos. That's why I put it in there. It's not going to be difficult. Okay, it's just going to be, use the little videos and examples so you know what to do. It's not, I should have given it to you before today, but I didn't, so it is what it is. But, so it's not due before Monday, but I highly, highly suggest that you look at it and at least do some of it before Monday so that what we do Monday in class will make sense, okay? So go and look at that because that's something that we have to do in our process on Monday. All right, that's again why that says this right here. Now, your quiz. Your quiz is in Delta Math. I think for my students it's supposed to post at 9:30, so I think you may not see it just yet. Oh no, it's supposed to post at 9. It's there. Okay. Don't start it just yet because you are going, well, you can start it because you've got 12 minutes, but it's a 12-minute, I'm sorry, I thought we got it at 9:50. I wouldn't have talked so long. You're going to have 12 minutes. So once you start it, you have 12 minutes. Have your graphic organizer ready. You don't have to do it right this second. As long as you get it done before 11:59, it's fine. Okay, does that make sense? So you just make sure you have your graphic organizer, make sure you have 12 minutes set aside, and get it done. Okay?